Hey everybody, so it's Miss Schoenfeld, and today we're going to be doing the Identifying Elements lab. Here I have several different elements. You don't know what they are. I'll give you a list later to tell you a little bit more about each one. Um, okay, so let's take a look at the different elements that we have. So we have sample 1. We have a few different varieties of sample 2. We'll look at all these in a second. Sample 3 is this one right here. Sample 4 is this one. 5 is right here and here. 6 is this one. I'm running out of space here. And 7 is going to be this little bitty thing right here. And then 8 finally is what's in this bottle. Okay, so let me see if I can adjust this screen a little bit. Get it a little bit closer. Sorry, y'all, I'm short. I don't have very much of a reaching range. Okay, so let's take a look at some of our tools that we're going to be using today. So first off, I have a set of magnets. The brown furry stuff on there is iron filings that have gotten stuck on there over the years. So in order to not get things messy, we're going to wrap the magnets in a paper towel. Okay, so like so. You can still see the magnets are in there. So we're going to be using these magnets to see if things are magnetic or not. We are also going to be using a conductivity probe. So let's look and see what a conductivity probe looks like and see how to use it. So I'm hoping the batteries didn't die over the summer. Looks like they haven't. But basically the way a conductivity probe works is you take one side of the lead and put one lead on each side of your sample. There's a little button to press on the side. Looks like this one may have died. And hopefully it should light up if it works right. Assuming that the batteries haven't died on you. Okay, so this is what it should do. So you should be able to put one lead on either side, hit the button and see that the green light goes up to the end if it is a good conductor of electricity. Okay, so let's put that one off to the side. Let's keep this one out. Okay. I apologize if I have to stop every once in a while and clean out my goggles. It's a little warm in here. It's first thing in the morning. It's like not even 7:30 yet. The light's going to start changing because it's dawn right now. It does get pretty hot in this lab, so yeah. Okay. Let's take a look at what we have. So, for each sample, we're going to test the conductivity using the conductivity probe. We're going to look at the magnetism using a magnet. On some of the samples, not all of them, but some of them, because some of them make a mess, we are going to test if it reacts with an acid by testing with hydrochloric acid and a pipette. And we're also going to see if it's malleable, brittle, and so forth. So let's take a look. So our first sample, so sample 1, is a sort of silvery colored, shiny, lustrous, I can't say what it is, but it's very shiny, and it is malleable, obviously, because it's hammered down into a flat sheet. You can also bend it, so further shows malleability. Let's test if it is conductive. So I'm going to take my probe. It went all the way up to 10. So you can see that little green light. That means it's up to 10. That means it's a very good conductor of electricity. Let's try the magnet. So let's see if a magnet will pick it up. So it is magnetic. Okay, that tells us a little bit. We're not going to test this one with the acid because these samples don't really work too well with acid. But if we were to test it, it probably would be reactive with it. Let's go on to sample 2. So in sample 2, I have this piece of something. You can see that it is very malleable. It has been bent into different shapes. Here I have another sample of it that the chemistry department has played with over the years, and you can see it is very malleable, very bendable. You can also see on the 2 samples, these are 2 samples of the same thing. One of them is very, very rusted. So you can see that it's got that brown, orangey color on it. It's very rusty looking. Again, both of them are kind of warped, so they are malleable. If I were to test this using a conductivity tester, so let's see. There we go, it went all the way up to 10. It's not giving me the best reading right now because it's got so much rust on it that it's not reading properly. But it is very conductive. Okay, let's see if it's magnetic or not. So I'm going to test it. Very magnetic. It holds very, very well to the magnet. Again, this one's kind of messy to deal with, so we're not going to test the acid with it, but it probably is reactive to acid. Okay, let's take a look at another one. So here we have another silvery one. So you can see it's kind of a silver color, more matte than the other ones. It's not as shiny. It's a little shiny. I can bend it pretty easily. We often see this one as foil, so like foil that you put on food. It's very lightweight. It's much more lightweight than this other one. So even though they're the same size, this one, number 3, lot less weight to it. So let's test the conductivity. So it goes all the way up to 10 again. Very conductive. Let's test the magnetism. Not very magnetic. It's not sticking at all to the magnet. So sample 3 may look like sample 1, but sample 3 is not magnetic. Okay, so that should give you a little bit of a clue as to what it might be. Okay, let's take a look at some others. Okay, let's look at, that was a 7:30 bell. Okay, let's look at the next one. this next one is going to be very different from the others that we've looked at so far. So this one is a yellow color. It's I'd say about like highlighter yellow. You can see there's big chunks in there. It looks kind of like eggs. It kind of smells a little bad like eggs. If I were to poke at this with my finger, it's very brittle. It's falling apart in my hands. It's like chalk almost. So very, very brittle there. If I were to test it out with the magnet, nothing's coming up. Not magnetic. If I were to test it with the conductivity tester, very, very difficult because it's a powder, but I mean, it's not showing hardly anything on the conductivity tester. It's like a 0. It is not conductive at all. So I can take a little bit of this, put it into a test tube. This one's a powder, so I don't mind as much. I'm just going to take a little bitty bit of it. My hands are going to stink a little bit after this, but I'll wash them off. Okay, so you can see there's a little bit of this element in there already. I'm going to take my hydrochloric acid, unscrew the cap. I'm going to take my pipette. We've seen these before. To use a pipette, you squeeze the bulb, put it into the bottle that you're taking from, let go to drop the liquid, and then you put it in the test tube and release. It's not doing anything. It's just sitting there like a big yellow lump. Okay, so this is not reactive with acid either. Okay, so overall, sample 4 is pretty much a dud. It doesn't react with acid. It's not magnetic. It's very, very brittle. You can't bend it. You can't turn it into a wire or anything. It doesn't conduct electricity. It's pretty meh. Okay, let's look at sample 5. Now, sample 5, I've got a couple examples of. So this is sample 5. You can see it's a very orangey color. A little bit of green on the side if you have an inclination of what it might be. This jar is also sample 5. So I have turned some of sample 5 into wires. You could make thicker versions of these and make electric wires with them. But you can see that it is very wiry, very ductile. I'm going to seal up the jar for right now because it's getting a little messy. If the jar will seal. There we go. It's a little bit of an old jar. Okay, so you can see that this has been hammered into a flat shape. It is malleable. It is also bendable, so malleable again. You can turn this into a wire as we've seen in the jar. Let's test the conductivity. Let me get it to where it's going to actually light up. Really? Looks like the probe might have gone out. All right, let me go see if I can find another probe real quick. Okay, sometimes this happens in chemistry labs where things don't go as planned. It happens. Really? Take my word for it. It is a very good conductor. Okay. So let's test if it's magnetic or not. Nope, doesn't stick. We've already seen the conductivity is not working at the moment for some unknown reason. Seems like the probes have all decided to quit, which happens. Okay. It is very conductive though. Again, we're not going to test the acid on that one because it gets a little messy with that one. Okay, let's look at our next one. So our next one is a big lump of coal. Okay, it's literally a piece of charcoal, like barbecue charcoal. So if I were to grind this up in my mortar and pestle, so I have my mortar and my pestle, and I whack it up, eventually I would get something that looks like this. I'm not going to spend the time to try to break down that whole piece of charcoal, but it would look like something like this. So little bitty black flakes. Okay? You can see I'm getting the stuff all over my hands. It comes off very easily. It is quite brittle. Breaks very easily, at least usually. Okay. If I were to test it using the magnet, nothing, doesn't work. Okay, the conductivity tester we decided was not working today. I can tell you this is not conductive. It is a very, very bad conductor. Okay, let's see what would happen if we took some of this and put it into a test tube and put some acid on it. So remember that metals are usually pretty reactive with acid. Non-metals are not. Metalloids are kind of meh. Somewhere in the middle. So I'm going to take some of this charcoal that I've ground up. Once again, I'm going to take my acid, carefully unscrew the cap. I'm going to take my pipette. I have my charcoal. A little bit of a reaction. Not very much, though. Probably from some impurities that are in there. And of course, I'm going to seal up my bottle again. Okay, let's take a look at the next one. So I have a little bitty strip of something. I don't know what it is. It's very shiny. It looks like it's got some black stuff. It looks like maybe it has oxidized a little bit. Classic symptom of a metal when it oxidizes a little bit like that. It is extremely malleable. I can twist this around however I like. Okay, so very, very malleable here. Let's test it out with the magnet. So, holding this little strip in my hand, not very magnetic. It doesn't stick at all. I'm going to keep trying this thing until I actually get it to work. But this is very conductive. It probably has a conductivity of about 10. So it's pretty conductive. Okay, let's see. So we've seen that it's malleable. I'm telling you that it's conductive. It's shiny, silvery color. Let's see, and it's not magnetic. Let's see how well it reacts with acid. Okay. So I'm going to take my sample. I'm going to put it into, I'm going to get one more test tube. I'm one short. Okay, so I have my test tube. I'm going to put my sample in there. So the sample, it's hard to see it because it's just a little bitty ribbon, but it's in there. I'm going to unscrew my acid. Take my pipette. And I'm going to put it in there. Now watch what happens, hopefully. Okay, so we can see there's a lot of bubbles forming. So you can see there's a layer of bubbles up there. You can actually hear it, like the Alka-Seltzer. Okay, so you can see there's like a watery part down here. There's a fizzy, bubbly part up here. And if you look really carefully inside the test tube, that is being chewed away. If you look at the very, very top, you can actually see some smoke coming out of it. So that's pretty cool. So it's producing a gas. You can tell it's very, very reactive. So we have different signs of a chemical reaction here. We have bubbles forming, we have sound, we have a gas coming out. All of those are signs of a chemical reaction. It's also heating up quite a bit. So if I touch it at the bottom, it's getting pretty hot. So I'm going to put this down, and we'll take a look at this in a few minutes. One last thing, just look at the bottom. You can see it is already chewing it away. It's kind of formed like a point, so it's not the same thing it was before. It's very reactive. Okay, and I'm going to seal up my bottle again. All right, last one. Okay, so I have a mystery one here. And these are all safe for me to touch, so that's why I'm not worrying about gloves or anything. They're all okay. I can see this one is a lumpy gray. It's kind of shiny if you polish it up, but very, very lumpy. It's sort of malleable. Yeah, I'm sure that you could probably squeeze it hard enough if you had a good press, but I'm not strong enough for that in here, so it is malleable, but not enough for me to do it. Magnetic, let's see. Not very magnetic. It's a great conductor of electricity, even though we can't test it at the moment. It's a good conductor of electricity. Okay. Let's look at this one with the acid. So this is the last one. This one is still kind of reactive. You can see there's bubbles forming, but not nearly as reactive as the other one. So you can see there's quite a few bubbles forming. I don't hear it as much as the other one, though. I don't see very much gas coming out the top either. So it is very reactive, but not, you know, extremely reactive like the last one. So let's compare. This was sample 7 that we just looked at. This is the one that was making all the noise and the heat and everything else. You can see that it is completely gone. It has like completely chewed away at the sample that was in there. It's gone. Bye-bye. Done. This one, it's more of a slow reaction. It's not, it's still going, but it's not going as rapidly. So I want you to think. They're both reactive, but which one would you find that is extremely reactive versus reactive but not like crazy reactive? That's the difference between 7 and 8. Okay, so that's it for the lab today. It was a pretty simple lab. I don't know what went wrong with the conductivity testers, but sometimes those things happen. Sometimes the equipment fails us. It doesn't work like it should. And that's nobody's fault. It just happens sometimes, especially when you're trying to do things quickly in the mornings. But anyway, I hope this was helpful. Be sure to go back and rewatch the video several times so that you get all of the information, okay?